Hello everyone! Welcome to the third part of this video lesson. I'm Teacher Jen, and this time I'll show you how to calculate current, voltage, and resistance. George Simon Ohm was a German mathematician and physicist who formulated the Ohm's law. Ohm's law is a very important law in electricity. It explains how voltage, current, and resistance relate. The formula on how to calculate the current is equals to voltage divided by resistance. When it comes to voltage, it is voltage is equals to current times resistance. And to calculate the resistance, it is resistance is equals to voltage divided by current. As we go on to this computation process, keep in mind the following symbols, units, and abbreviations. Again, the symbol for current is capital I, the unit is ampere, and the unit abbreviation is A. The symbol for voltage is capital V or E, the unit is volt, and the unit abbreviation is V. For resistance, the symbol is R, the unit is ohm, and the unit abbreviation is omega. Here's a sample problem. How much current flows through a lamp with a resistance of 50 ohms when voltage across the lamp is 20 volts? For this computation, apply the Gressa method. Given our resistance, which is 50 ohms, and voltage, which is 20 volts. Required is current. The equation to be used is current is equals to voltage divided by resistance. The solution is current is equals to 20 volts divided by 50 ohms. And the answer is current is equals to 0.4 ampere. What if the resistance is only 10 ohms? And the voltage remains the same, which is 20 volts. What do you think will happen to the current? This time, the given are resistance, which is 10 ohms, and voltage, which is 20 volts. Required is current. The equation to be used is current is equals to voltage divided by resistance. The solution is current is equals to 20 volts divided by 10 ohms. And the answer is current is equals to 2 ampere. Now, look what happened to the amount of current when we lessen the resistance from 50 to 10 ohms. It is a proof that when resistance decreases, the current increases. Or, if resistance increases, the current decreases. Using the same problem, this time let's increase the voltage into 50 volts and let's see what will happen to the current. 50 volts divided by 10 ohms is equals to 10 ampere. Now, look what happened to the amount of current when we increase the voltage. As the voltage increases, the current also increases. Here's another problem. Find the voltage if the resistance is 23 ohms and the current is 2 amperes. What formula are you going to apply here? Given our resistance, which is 23 ohms, and current, which is 2 amperes. Required is voltage. The equation to be used is voltage is equals to current times resistance. The solution is voltage is equals to 2 amperes times 23 ohms. And the answer is voltage is equals to 46 volts. Here's another problem. Find the resistance if the current is 1.5 amperes and the voltage is 8 volts. Given our current, which is 1.5 amperes, and voltage, which is 8 volts. Required is resistance. The equation to be used is resistance is equals to voltage divided by current. The solution to be used is resistance is equals to 8 volts divided by 1.5 amperes. What is your answer? Resistance is equals to 5.33 ohms. As the voltage increases, the current increases, provided the resistance remains the same. This is because the relationship between voltage and current is directly proportional to each other. On the other hand, if the resistance goes up, the current will go down. This is because the relationship between resistance and current is inversely proportional. Thanks for watching! Don't forget to like my video and subscribe to my YouTube channel.